I see that Kim has popped right up, which is perfect. So Kim Kraczon is the next speaker that I've invited today. Kim is the Director of Waste and Materials at Key Culture. Um, and Kim, I have to say, I didn't tell you this in advance, but just as Simona Kellerhoff was a name that I heard over and over again when it came to looking at topics of sustainability, reuse, yours was as well. Key Culture, your work with Key Culture, you as being a great resource. It just kept coming back. So I'm really glad that I was able to win you, both for the video that we're about to play, and for the Q&A period afterwards. So for everybody that's watching, we'll have a brief Q&A afterwards. But right now I'm going to play a video that Kim has provided for us. And I really love this because you have saved me getting into some of these details of what packaging is, what the labels mean, what the little things are. You know, in the past, I was taking time to try to read all these papers, and I love that you've really summarized this for us. So here is a video from Kim. I'm gonna have to switch to the video, which always takes a moment. And afterwards, we'll have a chance to talk to her. Oh yeah, sure.
Yeah, can I first of all thank you so much for inviting me to be a part of this initiative. As you continually mentioned, network is such a crucial factor in our aims and sustainability, and I couldn't be more happy to be a part of this. I do want to make a correction though.
Mhm.
We have stricken the word waste from our vocabulary
Oh,
at Key Culture because we
amazing.
want to urge the recontextualization of the materials that we use in the cultural sector and hope to reframe them as indefinitely useful and keeping them in circularity for as long as possible. So I'm the director of circularity and materials. It's I need to edit my signature and my emails still, but everyone just keep that in mind. So we're no longer using the term
I
waste.
love it. I think that updating these terms is great, and I think it definitely encourages us all to think about it differently. Perfect, thank you. Then with that, I will start the video that you've provided.
Hello, everyone. Thank you for joining me today. My name is Kim Kratzon. I'm a conservator of modern materials and contemporary art. I was previously the resident conservator at Studio Olafur Eliasson in Berlin for 8 years. I'm currently the director of materials at Key Culture, which is a nonprofit dedicated to sustainability in cultural heritage. I'm additionally a founding member of the Berlin branch of the Gallery Climate Coalition and the lead of the Gallery Climate Coalition's Packaging and Materials Research Committee. And today I will be discussing the challenges, of which there are many, of sustainable packing systems for artworks. Here's a brief outline of my presentation. I'm starting with an overview of synthetic packing materials and then discussing the pros and cons of various approaches to sustainable packing methods for artworks. This is followed by a case study of the packing improvements for Glasssphere artworks from the Studio Olafur Eliasson to illustrate how to implement sustainable packing methods for long-term transport and storage. I'll discuss alternatives to petrochemical packing materials, introduce a few examples of reusable crating and packaging, and then I'll quickly recap the guidelines for sustainable packing. When the studio started conducting a sustainability audits of source a few years ago, as the resident conservator, I turned my attention to the packing materials and methods we were using to create artworks in the studio. Anyone who is involved with creating artworks is aware of how much waste is generated from synthetic packing materials, especially in the context of one-way transport. We've always used traditional fossil fuel-derived synthetic packing materials in the studio, such as polyethylene foams, Tyvek, and bubble wrap. I'm sure everyone is familiar with these common packing materials. We use them precisely because they're tried and tested. We know that they're inert, durable, and won't readily degrade in the crates, which makes them ideal for art transport and storage. But these same material properties are obviously not desirable at their end-of-life scenario. As we all know by now, synthetic materials can take up to hundreds of years to biodegrade in landfills depending on the type of plastic, and recycling these synthetic materials is not always a straightforward solution. In the Waste and Materials Keybook, which is an online sustainability manual for materials in collections, care, and transport that I was at the helm of a few years ago, we impressed that these synthetic packing materials, Tyvek, polyethylene foam, bubble wrap, plastic wraps, although theoretically recyclable, as companies claim, aren't typically curbside recyclable, meaning picked up by waste collection services, and usually end up in the landfill or incinerated. If you are interested in downloading the manual, it's free on the Key Culture website, and I'm currently working on an updated version that will be available online in the near future. As many of you are also probably aware, plastic recycling isn't as commonplace as we've been led to believe. I'm sure some of you have come across the stat that only 8 to 9% of plastics ever manufactured have been recycled. The recycling myth can also be applied to the synthetic packing materials that we use in shipping artworks. We discard our plastic waste in the Gilbetunnel in Berlin, but many of those plastics aren't recycled for a few reasons. First one being the challenge of sorting different types of polymers for the recycling process. Plastics are recycled by their polymer group, of which there are 7, and can't be mixed together in the recycling process. Sorting the various polymer types is expensive and the technology is lacking. Piggybacking on that concept, products and packaging waste comprising 2 or more different polymer types cannot be recycled. Bubble wrap, along with plastic films and bags, also pose a problem in these facilities because they get caught in the machinery. I contacted BSR in Berlin to inquire about the likelihood of these standard packing materials being recycled, and they verified that they do not recycle Tyvek packing foams and bubble wrap. Only 30% of plastic packaging is recycled by BSR, and the rest is incinerated. So this is a handy plastics resin table in the Waste and Materials Keybook, outlining the different types of plastics we encounter in collections care and art transport, along with information on their general recyclability or lack thereof. This is a general guide, but it's important to keep in mind that the recyclability of plastics is regionally specific. Tyvek, for example, offers a take-back program where you send Tyvek in 50-kilogram minimum batches directly to a recycling facility in Bad Zoberheim. The manufacturer of the polyethylene foam in the studio also offers recycling, but only if we're able to fill a huge lorry with foam scraps that would first be shipped to Eastern Europe for processing, and then back to Southern Germany for foam production. Not only is it difficult to find storage for large amounts of foam scraps, but the transport involved doesn't make much sense as far as carbon emissions. TerraCycle is a company that offers recycling programs for many difficult to recycle plastic products, but doesn't offer these services in Germany. So if recycling isn't a viable option for many of our packing materials in Berlin, what are the sustainable alternatives? Well, it's a complicated question because of our concerns over material compatibility, meaning between the packing materials and the artworks, as well as the packing standards we have for artworks. So when tasked with finding sustainable alternatives for our packing systems, my first inclination was simply switching out traditional synthetic packing materials for one of the many materials available on the market manufactured from natural renewable resources that are either biodegradable, compostable, or curbside recyclable. Some examples of these materials are paper-based products such as corrugated cardboard, shredded paper, filled paper cushions, and molded pulp. I was also looking into cork and natural felt. And then of course we have the bio-based foams made from cornstarch and other vegetable starches, PLA, which stands for polylactic acid, and mycelium, which is produced from the tubular filaments of fungi. I would like to take a moment here to define the terms biodegradable and compostable because it's crucial to understand these terms when researching green materials. Biodegradable means decomposition by a biological process into water, carbon dioxide, and biomass without human intervention. There's no implicit time frame for the decomposition rate, meaning we can label a material that requires 1,000 years to biodegrade as biodegradable. It's important to add that biodegradable materials, even paper-based products, don't typically biodegrade in municipal solid waste landfills. Compostable is biodegradation of a substance through human intervention, which is to say home compost or industrial compost facilities, which require controlled environments and high temperatures. The additional caveat for compostable materials is that the biomass, meaning the compost, produced in the end can safely be used as fertilizer. So these alternatives to synthetic packing materials have many desirable properties as sustainable materials. They're manufactured from renewable resources or recycled materials instead of fossil fuels. They have a much lower carbon footprint or negative carbon footprint, as is the case with mycelium. They're non-toxic and can be disposed of with less detriment to the environment. So this is cornstarch foam up here in the right-hand corner. We come across it typically in the form of packing peanuts, and it's 100% dissolvable in water. Mycelium is 100% natural and will biodegrade in water or soil within 90 days, which sounds great, right? These natural materials initially seem like a good solution as alternative packing materials, but they also have properties that can potentially render them inappropriate for use with artworks. They have a shorter lifespan than traditional synthetics, which means they degrade over time and which alters their physical properties. Some are hygroscopic, meaning they attract moisture from the air and can expose artworks to moisture, which we want to avoid. When some of these materials are exposed to moisture, they are potentially susceptible to mold and fungal growth. The paper-based materials also become acidic over time and can't be used in combination with all materials. Some also simply don't have the necessary physical properties to prevent damage to artworks in transit. I do want to stress at this time that I believe these natural packing materials can find application in short-term transport with certain types of artworks, especially when we are certain that someone is on the receiving end to remove the artworks from crates within a reasonable time frame. So how can we pack artworks with less environmental impact if we aren't always able to use these alternatives to synthetic packing materials? When thinking about using synthetic materials, it's useful to reference the 5 R's in the waste hierarchy. This is also a page from the keybook. At the top of the hierarchy is refuse, but as I just outlined, this isn't always an option because there aren't suitable alternatives for long-term transport and storage. But we can focus on the next 2 R's in the hierarchy, reducing and reusing. With the considerations for long-term transport and storage and the waste hierarchy in mind, one can use archival synthetic materials but rethink crate design to reduce the amount needed for the safe transport of artworks. In addition to reducing the amount of materials, also try to purchase foams, plastic films, and bubble wrap with recycled content or plastics that are partially bio-based. For example, polyethylene foam manufactured with green solvents. It is also imperative to do some research into manufacturing and distribution locations of products and try to order from the closest supplier to Berlin to minimize carbon emissions. So now I'm going to walk everyone through the evolution of packing methods for our glass sphere works in the studio. So glass sphere works is the term we use in the studio to describe artworks installed on a wall comprising various sized glass spheres. These spheres range in size from a diameter of 30 millimeters to a diameter of 400 millimeters, and the number of spheres involved in these artworks can range from as few as 12 to over 1,000. This is an example of how we previously packed glass spheres. Each sphere is individually wrapped in Tyvek and then packed on top of a polystyrene, which means styrofoam, base. The spheres are then additionally surrounded by strips of polyurethane foam topped with another layer of polyurethane foam. An empty space in the crate was filled with even more polyurethane foam. It's actually quite painful to look at. Because polyurethane foam isn't archival and can damage the material components of the spheres, on top of not being the most environmentally friendly material, redesigning the glass sphere crates took on urgency, and we started thinking about new packing methods. So the concept for redesigning the glass sphere crates centered around utilizing all the space in the crates, implementing packing materials that are archival and durable for reuse, but also reducing the amount of these materials. And of course, our number one concern is to ensure the glass spheres arrive safely at their destination and can remain in their crates for long term if necessary. The spheres are sandwiched in between 2 layers of polyethylene foam with holes corresponding to the size of the spheres to prevent movement during transport. Small blocks of polyethylene foam on the top layer apply pressure to the spheres when the crate lid is closed. Instead of individually wrapping each sphere, the idea was to use one singular sheet of Tyvek that protects the coated surface of the glass sphere from abrasion during transport. This new method significantly reduced the quantity of Tyvek and foam in the crate. We conducted a test run with a mock-up crate, which you can see here. We dropped the crate, tipped it over, and sent it on a joyride through the streets of Berlin. The glass spheres did not budge, and we felt confident applying the new packing method to artworks. After repeatedly testing the newly designed packing system, we settled on implementing a combination of sustainable approaches on a case-by-case basis. We minimized the use of synthetic materials and allowed some naturally derived materials in the crate when we know an artwork will be immediately uncrated. For this particular crate, we used cardboard instead of foam blocks to apply pressure to the spheres. I know I previously stated that cardboard wasn't archival, but we knew this artwork would not stay in the crate long term. And if the artwork does stay in the crate long term after transport, the cardboard can also be removed. So if you're using one of these systems with cardboard or paper products, it's imperative to label the crates and notify the people on the receiving end that either the paper-based materials or the artwork needs to be removed immediately. So branching off from the mention of cardboard, I'd like to discuss paper-based packing materials. We can use non-archival paper-based products depending on what we're packing. Waffle and honeycomb structured packing materials made from recycled paper can be used in some cases as a replacement for bubble wrap and polyfoams and even foam corners. But there are some caveats for their use. One issue is that they don't necessarily provide the same shock and vibration absorption as polyfoams and should therefore only be used when the durability or weight of the artwork, packing methods, and type of transport are appropriate for their use. Unbuffered recycled paper is also acidic and becomes more acidic over time, which means these materials should not be used for long-term transport or storage in conjunction with materials and artworks that are sensitive to acidic conditions. Cardboard, craft paper, paper bags filled with shredded paper can also find application as filler material when packing particular components of artworks that are a bit more durable, such as structural elements, hardware, and technical components. Here's an example of filled paper bags as an alternative to foam as a filler material around an already encased object. I'm sure many of you have come across various bioplastics or bio-based products when searching for sustainable packing materials. So let's first define these terms. Bioplastics are plastics that are either bio-based, biodegradable, compostable, or both. This means that even traditional petrochemical plastics, such as polyethylene, can be manufactured with additives to catalyze the degradation process and still fall under the definition of a bioplastic. Bio-based plastics, however, are plastics partially or 100% derived from renewable biomass, such as corn, sugarcane, and cellulose. Non-biodegradable PE can also be manufactured with ethanol derived from sugarcane and fall under the definition of bio-based. So the biggest takeaway from defining these terms is that bio-based doesn't always indicate that the material is biodegradable. It's pretty much greenwashing and something to consider when purchasing bioplastics. Another important thing to note when using bioplastics is that they also have a shelf life and can only be used in short-term transport. Another example of greenwashing is so-called compostable plastics. There are some eco-friendly bioplastic products on the market made from PLA, which claim to be DIN certified 100% compostable. But this particular material requires industrial composting to degrade, meaning high temperatures and controlled conditions. These facilities are not very common, and we certainly don't have them in Berlin. So when we throw away PLA in the regular trash, it doesn't compost and behaves as any other petrochemical plastic that ends up in a landfill. Compostable plastics additionally don't add any nutrients to the compost, which makes them undesirable for many industrial compost facilities. Another issue with PLA is that it's often confused with other recyclable plastics and contaminates the recycling stream. But in comparison to petrochemical plastics, PLA does have a significantly lower carbon footprint, so purchasing this bioplastic isn't entirely bad. Plus, Berlin incinerates much of its household waste anyhow. But I just want to impress that it doesn't magically dissolve when discarded in the trash bin and definitely cannot be composted in home compost bins. And this up here in the center is the logo for compostable plastics. It's very misleading. This is actually a logo for the industrial compost. So how do we keep all this information straight? This is a project I'm developing with the Gallery Climate Coalition's Material and Packaging Committee. The aim is to determine the suitability of bio-based materials and bioplastics as packaging materials for artworks, which involves evaluating the materials in conservation labs and in field tests to assess their degradation and material properties, and then additionally asking art technicians to test their viability as packing materials. Point being, if a biodegradable cellulose-derived plastic film tears when wrapping an artwork, then we can't use it anyhow. On the GCC website, you can find the traffic light guidelines for many alternative packing materials. The color-coded system of red, amber, green indicates the use of these materials in short-term transport, which I would define as under a week, long-term transport, and storage. For creating artworks, there are a few reusable crates on the market from Rockbox and Turtle. They are constructed from impact-resistant plastics, and the artwork is secured mechanically inside the crate. Both companies replace damaged or worn out internal components indefinitely. Using one of these crates in lieu of wooden crates over a 15-year span can save tens of thousands of euros and save up to 40 trees. These crates are obviously intended for framed works, but I know both companies are currently developing crates for objects as well, so it's worth staying tuned into them. They are, however, a bit pricey. As an alternative, we have the Biomap, which is a company from the Netherlands that produces reusable soft pack padded bags for framed works and are perfect for intracity transport or can also be used within other crating systems. If you are working on a budget, which so many of us are, perhaps investing in a reusable crate isn't an option. Berlin-based art transport and logistic company ArtSeco recently created an online crate bank for the resale of wooden crates. Also, if you have wooden crates to donate, you can redeem them for a voucher to use for the future purchase of a crate or in their web shop. So just to recap, here are some general guidelines. Assess whether the crate and packing materials are intended for one-way transport or for multiple transports and or storage. If the transport is one-way and the person on the receiving end plan on discarding the crate and packing materials after install, consider using curbside recyclable or biodegradable packing materials derived from natural renewable resources, if applicable. If an artwork is scheduled for multiple or long-term transports and storage, durable archival packing materials, meaning fossil fuel-derived synthetics, are most likely necessary, but this is an opportunity to design the waste out of crates, which requires sufficient time and planning to customize crates. So if the use of synthetic packing materials is unavoidable, look for materials with recycled content or manufactured with renewable natural resources. Note that bio-based does not necessarily indicate that they're biodegradable or compostable. Repurpose packing materials at the end of their life cycle in art transport for other shipping needs. When purchasing packing materials, try to purchase from local distributors and suppliers to reduce the amount of carbon emissions from shipping over long distances. Connect with others in your area to order materials in bulk to minimize costs and carbon emissions. The Berlin branch of the Gallery Climate Coalition offers a forum for this purpose, as well as a forum to share exhibition furniture and transport to fairs and yeah. So then if in doubt about the environmental impact of a particular material, use the below resources to compare the LCA, meaning life cycle analysis, carbon footprint, ecotoxicity, etc. So thank you all very much for your attention. Here is a list of some of the resources that I mentioned in my presentation, and I look forward to hearing your feedback and questions.
Thank you very much, Kim. I'm hoping that my internet didn't cut out again and that everybody got to see the full presentation. Um, I just want to mention again that the list of resources that Kim showed at the end, we'll be adding those to the Primal Green Resources website. Kim, you also mentioned the Gallery Climate Coalition, which has a fantastic resource page as well. Yeah, it's a really great resource and destination for anybody interested in learning more. Much to my horror, during the presentation, I've realized that I've been ordering the wrong cups for the Berlin Art Prize, I believe, and using non-recyclable or non-compostable or industrially compostable plastics. But I see that we actually have a question about the plastics right off the bat, which is producing the bioplastics at least more sustainable than the others? Maybe you could get into the plastics and cups, and since a lot of us are involved in events.
Yeah, I mean, I think it depends greatly on what type of bioplastic. For example, if if the manufacturing of a plastic or bioplastic, I use this example as well, requires sugarcane.
Mhm.
Then if sugarcane as a monoculture is grown, I mean, that's the thing, you have to kind of like trace the supply chain back. If it's grown somewhere that's wiping out,
Oh,
um, the, the agricultural means for indigenous cultures, we have to think about that as well. But generally, yes. And if in doubt, I did provide the resources. You really have to look at the LCA, the life cycle
mhm.
analysis. That's kind of the go-to when analyzing the sustainability factors of materials. And IDAMAP is a downloadable app for your phone that I find incredibly useful, and Stitch as well. It was constructed by conservators, and many of the packaging materials that we encounter are listed on their website as well. So you kind of have to do your own research. I mean, there's not a blanket yes or no, but generally yes.
Mhm. And, if there's, there's always an uproar around recycling in Berlin and whether things are actually getting recycled, and it seems like there's a lot of conflicting information out there. If there's one thing that you think that people could do better, when it comes to sustainability, whether it has to do with recycling or using different materials, what would you advise?
Don't recycle.
Mm,
Reuse the materials. I mean, that's
mhm,
in the waste hierarchy. We also see recycling as the very last resort. Recycling also requires lots of energy, the transport to and from the facility, and if you can keep the material out of the recycling stream, that is the best means to go about it. We're thinking about circularity,
mhm.
which is a topic later, I believe.
Right,
Um,
exactly.
uh, so yeah, just try to, yeah, also purchase things that don't involve one disposable one way
Mhm.
or one use plastics.
Great. I mean, great advice. And we don't have so much time. It's a great talk you gave, but you're currently in Amsterdam, and I'm
Okay.
wondering what's coming next as far as you're studying. You're continuing your studies in packaging, right?
Well, in art conservation, in contemporary art
Okay.
conservation, I have
And
to, yeah.
so what do you see coming next as far as conservation or in your field?
In my field, I know that recently the Sustainability in Conservation, it's a sister organization of Key Culture that was also founded by Caitlin Southwick, recently published a green solvents handbook for conservators and discusses the use of the chemicals that are necessary often in the treatment of artworks. And that's a great resource if anyone is interested in that, or anyone who uses solvents in their practice. It's worth checking out. But then also maybe a plug for the Berlin GCC, which I'm also a part of, and in our discussion about networking. Um, and you're hearing it here first. We have a event plan for May 6th, um, with panel discussions and workshops with all the members of the Berlin GCC. So keep an eye on that. We'll be announcing it next week. And for anyone who's interested in learning about the networking we're doing in Berlin, please come and say hello. Very friendly group of people, and that's the thing as well with networking. It's or finding networks. It's very daunting to reach out, but it's worth it.
I think that if there's one thing that's been shown over the last 2 days is that everybody is very open to being reached out to. So, uh,
Absolutely.
fantastic. Thank you so much for your time.